Good day, everyone. Today we shall be considering mesh analysis. Well, it is also known as loop analysis or mesh current method. It applies Kirchhoff voltage law, that is KVL, to find a mesh current and a branch current in a given circuit. These two doesn't mean the same thing, branch current and mesh current. Well, I'll be explaining further. Well, steps to analyzing a circuit by mesh analysis. Just 3 steps. First of all, assign mesh current I1, I2, I3 till the n number of meshes you have. Again, apply Kirchhoff voltage law to each of the meshes using Ohm's law to express the voltages in terms of mesh current. And then lastly, solve the resulting simultaneous equation to get the mesh current. After which, if you want to get the branch current, if it's required in the question, then you can do that. Well, let's illustrate all we are saying here now. When we say mesh, what do we mean? It is a mesh, a closed conducting path in a circuit where no other elements is encountered, no elements are encountered twice, meaning going like this. Well, all of this introduction actually, or defining mesh or loop and branch, was done in our introductory class on circuit theorem. So you can watch the video for that, and I'll be dropping a link to that video. But I'm trying to say that this is a mesh and also a loop, and this is also a mesh. And each of these meshes now, there are currents in them. We've assigned I1 for the first mesh, I2 for the second mesh. So if there's a third mesh, I3, fourth mesh, you can have any number of mesh depending on the kind of question given to you. So that's about that. We're not giving branch currents here. If you're giving branch current, if you see something like I here, this is referred to branch current, or if not written like this, it will be written like this. We use capital I, not to confuse it with small letter I. So well, that's that about that. But we don't want to go into the branch current, because we don't need the branch current to solve this circuit. All we need are the mesh current, which is small letter I1 and small letter I2. So we've assigned our mesh current now. So let's apply the mesh analysis here now. After assigning our I1, I2, I will use KVL to read the sum of voltages here. KVL, Kirchhoff voltages, let me say, when you sum all the voltages in this mesh, you equate it to 0. And like I said, this is a mesh and also a loop. And so let's sum up the voltages now. What would we have? Let me read the voltages here. This is I1, R1. That's the voltage in this resistor. I'm using Ohm's law. You know, voltage V is equal to IR. That's Ohm's law. So V is equal to I1, R1. Now, the current across this resistor is I1. The current across this resistor is also I1. This I1 flows across any resistor you can find here. So that's why it's I1, R1. Now, the next one is my cell, and that will be E1. And then lastly, for this one here, the next one, not the last one, sorry. It will be I1, R2. But I need to be putting, is it plus or minus, positive or negative voltage? Well, this is negative, and this is positive. The question is, why is this one negative? Well, I have an easy way of making this less stressful for anybody. Any resistor you meet in any mesh, just take it to be negative voltage. So there's a negative voltage or a voltage drop to every resistor you meet. Why? I simply made an assumption that the direction of my current is the direction I'm taking in reading these voltages. You know, I read this first, and I read this next. I'll be reading this last one next. So you see the way I'm going now, going like this. And if you look at this current is going in this manner. So because of that, always a negative voltage or a voltage drop. But for your cell, we don't use any of this method of reading. What we do is that since I read this and I'm going to read this. In a cell, it has the short arm and the longer one. The longer one indicates the positive and the shorter one indicates the negative. You see, after reading this now, before reading my cell, it means that I'm going like this and like this. If going like this now, which one will you see lastly? You will realize that you will see this longer arm lastly, because you will meet the negative before the positive. So since you meet the positive lastly, that's why this is positive. So in reading, since I'm reading like this and like this and then like this, when going like this, for this cell, it is the one you see lastly that tells you the voltage is going to be, and that's why it is positive E1. And then for this one, you know, it's I1, R2 and negative because all the resistors is negative, like I said. Now the next one is this one now. For this resistor, you see, it's between these two mesh, this first mesh and this second mesh. So these two currents will flow through it. But understanding the pattern through which they flow. For this I1, if you check this I1 goes like this and then flows down. When it gets to this middle part, it flows down. And if you look at this I2 in the middle part, how does it flow? It flows upward. This I2 flows upward, while this I1 flows downward. So in essence, it will be negative as well. Like I said, it's always negative. But it's going to be I1 minus I2. Then times this resistor. Now, first of all, understand that it's going to be a combination of this current and this current. But the question is, why is it minus? Because they are in opposite sense. Why this I1 is flowing downward in this middle part, this I2 is flowing upward. So because they are in opposite sense, it's going to be subtraction. The next question is, okay, it's going to be subtraction. Why not I2 minus I1? Why is it I1 minus I2? I1 minus I2? Well, for this, I am taking for the first mesh, for mesh 1. Meaning that I'm considering this mesh firstly. So if I'm considering this mesh firstly, it's going to be I1 minus I2. When I'm considering the second mesh now, it's going to be I2 minus I1. Understand why is it negative again? It's negative because they are in opposite sense. Why this I1 will flow downward in this middle part, this I2 will flow upward. You can see the current direction flowing upward. So that's that about that. And finally, you say equal to 0. That's what Kirchhoff voltage law is saying. Now, when you sum up all the voltages of everything you can see here, you equate to 0. So I have sum up this voltage, which is this. I've taken this voltage, which is this. I've taken this voltage, and lastly this voltage. There's nothing else I can see in this first mesh, and I say it's equal to 0. You can go ahead to simplify this actually. Opening the bracket here and all that. But that's that about that. Now, for the second mesh, for mesh 2, how is it going to be? Now, let's begin from this part and go like this. You see the way I'm going? I'm simply trying to follow the arrow 2. I will read this first, read this second, read this third, and that's all. Another person can choose to go like this. But me, I often follow the direction of the current. That's how I read. So I'm going to read this first. You can start reading this one first. It does not do any harm to the question or to the solution. Or you can read this one first. But the fact is that using my own approach, if you are reading this first, still maintain the pattern, keep going like this. Don't read this and come like this, then you're opposing the method I gave to you. So let's start with this actually. Starting with this, understand that this resistor R3, these two currents flows across this resistor. So this time around, it's going to be minus I2 minus I1 because I'm taking mesh 2 now, then times the resistor. Why? Because Ohm's law, current times resistor, gives you the voltage across this. For this one, only I2 flows through it. I2 flows through this, I2 flows through this. Any other resistor in this part, I2 will flow it apart from the one in the middle. The one in the middle, the two currents will flow across that one in the middle. So let's look at this one, and this one will be minus I2 R4. Again, look at this cell now. Nothing concerns me with how current flows to reading this cell. I have read this, I have read this. In reading this one, which one will I see lastly? I will first of all meet the positive and then meet the negative lastly. Because I'm meeting negative lastly, it will be minus E2. And then for this R5, this R5, not R4, please, my pardon. This will be minus I1 not I1, I2 R5. I've read this voltage, is it? I've read this voltage, this is it. The voltage in the cell, they just E2. You don't use Ohm's law to read that one. The voltage is given to you. And then finally, this one here, I2 R5. Everything is equal to 0 according to Kirchhoff voltage law. So this becomes our first equation, and this becomes our second equation. We'll all be applying this now to a practical question. So we'll take our example 1. Okay, so example 1 now. For the circuits below, find the mesh currents using mesh analysis. Also determine the branch currents I1, I2, and I3. So this is the branch current I1, I2, and I3. But I don't solve mesh analysis using this branch current. No. So if you look at this question now, our mesh current is not assigned to us. The mesh current are not here. And that's what we used to solve. So the first thing you do is to assign your mesh current. In some question, you might be giving the mesh current already. In fact, most lecturers like giving their mesh current because when students assume different direction, it will cause one getting different answers. The magnitude of the answer, the value of the answer will be the same, but when I have minus, you might have plus, or because we assign different direction, but the value will be the same thing, just difference in sign. But that's about that. Now we're not giving our mesh current here. No mesh current is here. No mesh current is here. So I'm going to assign now. I've assigned the first mesh, calling this one mesh 1, and that I gave it I1. I'm calling this one mesh 2 now, and now I'm giving it I2. I can choose to assign in any way I like, or I choose actually, and that's because no direction was given to me. So I haven't done that. Now let's go ahead to solve this question now. We can now say, let me start by reading this. I love starting from here. You can start from anywhere actually, but make sure you don't read a circuit element twice. Circuit elements are like this resistor, this cell, and whatever you see else there. So now let's take this now. This is positive 20. Why is it positive 20? You know I'm going like this now. I'm following this guy, this current direction. So I'm going like this now. I'll see the positive lastly. That's why it's positive 20. Then for this, it is minus 5I1, or I1 times 5. That is 5I1. Current and the resistor. That's Ohm's law. IR. Remember now, IR. R1 is the value is 5 ohms. So 5 times I1. Then when I get to this middle one now, understand that these two currents will flow across this middle part. And so because of that, it's going to be minus, write the value of your R first, 10. Then into brackets, I1 minus I2. Now why is it I1 minus I2? The I1 is flowing downward in this middle part, while I2 is flowing upward. That why it's I1 minus I2. And then I'm starting with I1 minus I1, not I2 minus I1, because I'm doing for mesh 1. So I ought to say for mesh 1 first. So you understand that I'm doing the mesh 1. So this is for mesh 1. Then lastly, I will see this voltage. Which one will I see lastly in this voltage? Obviously, this is negative arm I will see. So that is minus 10. I'm done reading. I've read this. This is it. I've read this. This is it. I've read this R3, which is 10 ohm times the current. This is it. And then for the cell, minus 10. This is it. Is equal to 0. Let's simplify this. If you simplify, you get 20 minus 10. Well, that's 10. Minus 5 I1. Minus, opening this bracket, minus 10 I1. Plus 10 I2 equal to 0. I've combined these two. So at the end of the day, this will give us 10 is equal to this minus this. We give me minus 15. If I let me do that, let me simplify. Let me not rush things. Then plus 10 I2 equals 0. So at the end of the day now, this will give us 10 is equal to 15 I1, because I'm bringing to this side 15 I1 minus 10 I2. This is my equation 1. Now for mesh 2, what is it going to be? Well, quite simple. Again, let's start from the middle part. This will be minus 10 into I2 minus I1. Now it's going to be I2 minus I1, all because I'm not taking mesh 2. So you always begin with 2, then minus the first one. And why is it minus? They are in opposite sense. Why one goes upward, the other one goes downward. Then, oh, I didn't read this. What I read, I would have read this first. If I read this first, this is plus 10. So let me start again, please. 10 first. Why? I'll be seeing the positive arm first. And then I'll read this. Plus, minus 10 into I2 minus I1. So this 10 is for this voltage, this cell, it's voltage. And for this one now, this is it. Then minus again 6I2. And then minus again now 4. It's always minus, 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 minus. That's why I made that assumption. I didn't see it in the textbook. I just know that it's going to give me something easier and quicker than any other method, any other means you want to use. So, and it does not mean that my equations will be different from what or any other textbook. If we solve the same question using any other method, we will have the same answer, but this method is faster actually. So equal to 0. Now this is going to be 10 minus 10 I2 plus 10 I1 minus 6 I2 minus 4 I2 equals 0. So at the end of the day, this will be 10 minus 10 I2 minus 6 I2 minus 4 I2, that give me minus 20 I2, and then this is plus 10 I1 equal to 0. So let me bring all of this here. This will give me 10 is equal to minus 10 I1 and then plus 20 I2. This becomes my equation 2. So I can say simultaneously solving now. Simultaneously solving equation 1 and 2. So our equation 1 says 15 I1 minus 10 I2 is equal to 10. And equation 1 says minus 10 I1 plus 20 I2 is equal to 10 as well. Okay? Well, from here now, what do we do? This is equation 1 and then this is equation 2. Well, I'm not supposed to solve this simultaneous equation here because this study is not focusing on solving simultaneous equation. I assume that you ought to have a prior knowledge on solving simultaneous equation. But this is example 1. So let's quickly solve this question. I just simply multiply equation 1 by 2. So if you've not learned simultaneous equation, you can go and watch our gifted brain video on simultaneous equation too. I'll also drop the link on my bio. So this is 2 times this now. This will give us 2 times this will give us 30 I1 and then minus 20 I2 is equal to 20. Why this one? I'm leaving it the way it is. Minus 10 I1 plus 20 I2 is equal to 10. So right here now again, this can be called equation 3 and this can be called equation 2 because equation 2 I didn't touch it. Now you can sum them up. This added to this will give us 20 I1 and then this added to this will be eliminated. Then 20 plus 10 will give us 30. And then from here, I assume we can get our I1 now. So I1 will simply be 30 over 20, which is 1.5 ampere. So we've gotten that now. I don't want to clean the question or the diagram because we have to get with the branch current. So let me just clean this. If we've gotten I1, we can put that I1 into any of the equation. Let's put into equation 2. So put I1 is equal to 1.5 ampere into equation 2. And so this will simply be 15 multiplied by, equation 2. So minus 10 multiplied by 1.5 ampere, 1.5. Then plus 20 I2 is equal to 10. If I open this bracket, I will get minus 15 plus 20 I2 is equal to 10. Bringing this here will give me 20 I2 is equal to 10 plus 15. And that will be 20 I2 being equal to 25. And so I2 will simply be 25 over 20. And this will give us 1.25. 1.25 ampere. So that's that about that. So we've gotten our I1 and I2, which is the mesh current the question actually asked us to solve for. Now, we need to get our branch current now. So it's after solving the mesh question using the mesh current that you cannot go and get your branch current. So the branch current, this I1, I2, this capital letter I1, I2, and I3 has no business in solving the mesh question. It's when we are done solving by mesh analysis that we cannot go back to go and get our branch current. Now, let me solve the branch current now. For the branch current, let's get the branch current now. The branch currents. Okay? So, now, understand that this capital I1 is what flows here, here, and here. And obviously, it's going to be the same thing with I1. Why? Because I1 also flows here, here, and here. So, we can say that this capital I1, which is the branch current, is sent as the mesh current I1. And therefore, the value will be 1.5 ampere. Now, understand again that this I2 is what flows here, here, and here. And this I2 also flows here, here, and here. And therefore, we can say that our I2 is equal to I2, which is 1.25 ampere. So that's that about that. Now, lastly is I3. There are different ways to get the I3, you can apply Kirchhoff current law, which is your KCL. You can say, taking this node, for instance, say entering is equal to leaving. The current entering this node is the I1. I1 will come and enter this junction. Why this I2 is not entering the junction, it's leaving the junction. And this I3 is leaving. So you say entering is equal to sum of current entering is equal to sum of current leaving. And so that would be entering is I1 and then leaving is I2 and I3. So this KCL actually to node B. To node B. I call this node B. So to node B. And so you cannot get the value of your I3. We've gotten I1, yes. We've gotten I2, yes. We get I3. Just bring this one here. You can say I1 minus I2 is your I3. And so you understand now that if I take I1, which is 1.5, minus I2, which is 1.25, I will get I3. So what's the I3? That is 0.25 ampere. So that's that about that for this question. Example 2. For the circuit above, find the mesh current using mesh method and also determine the branch current I1, I2, and I3. For this question, the branch current has been given to us. We can see that now, I1 and I2. The mesh current has been given to us, I1 and I2. So now, the branch currents, we have to also find it. This capital I and capital I, I1, I2, and I3, capital I's. We have to get them too. So, to solve this question, we apply the same principle to. Let's start from here again, or we can start from anywhere. Let's start from here. This will be minus 2 I1, because this thing is going like this. Then plus 4. When we get to the middle part, now I've read this plus 4. Nothing to read here. So I'm reading the middle part now. This will be minus 4, that's the resistor, into brackets. This will be I1 plus I2 this time around. Now, so you have to be careful here. Now, check. How is I1 flowing in the middle part? It's flowing downward. How is I2 flowing? It's flowing downward. And that's why it's like this. So at the end of the day, nothing else to read here. So I've read this, read here, nothing to read here. I've read this, nothing to read here. Equal to 0. I'm done with the first mesh. We can simplify. This is minus 2 I1 plus 4 minus 4 I1 minus 4 I2 is equal to 0. Again, we can say this is 4 is equal to minus 2 I1 minus 4 I1 give us minus 6 I1. So let's minus 6 I1 and then minus 4 I2 equals 0. So we can bring everything to this side of the equation. That will give us 4 is equal to 6 I1 plus 4 I2. This is my equation 1. Again, for mesh 2. So this is for mesh 1, please. Now for mesh 2, which is this now. Nothing to read here. I want to start from here. I don't want to start from the middle part. Let's start from here. Nothing to read here. Now reading this part now, it will be, sorry, I'm not reading like this. I'm reading like this because of this current direction. So let's read now. Starting from here, this will be minus 1 I2, which is like minus I2. Because, you know, we are going like this. And so, it's still minus also. But, the resistor times the current, I2. Now, for this, this will be plus 2. Now, nothing to read here. Now, let's read this one now. This will be minus 4. But I2 minus plus I1. Starting with I2 first, because I'm doing mesh 2. And it is plus because the two of them are in the same direction. If you look at I2 is flowing downward, look at this one, it's flowing downward. So this guy is telling me how to read my circuit elements, reading the voltage across my circuit elements. This guy, the direction like this. So that's that about that. Nothing else to read in this mesh. Say is equal to 0. So you can simplify these two. This minus I2, this plus 2, minus 4I2, minus 4I1 is equal to 0. Okay? With this now, we can rearrange. This will give us 2 is equal to 2 minus 4I1 minus 5I2 is equal to 0 because this added to this give me minus 5. So eventually this will give us 2 is equal to 4I1 plus 5I2 is equal to 0. So simultaneously solving now equation 1 and 2. This is my equation 2. So simultaneously solving equation 1 and 2. Equation 1 says 6I1 plus 4I2 is equal to 4. This is equation 1. And equation 2 says 4I1 plus 5I2 is equal to 2. This is equation 2. So if we solve simultaneously, I'm just going to give the answer. If we solve simultaneously, we get I1 to be equal to, solve this in my material before, so minus 0.86 ampere. That's my I1. And my I2 is 0.29 ampere. You can solve that on your own actually. So I've gotten my I1 and I've gotten my I2. The next thing to do here now is to get our branch current. We can tell now that our I1, to get the branch current now, the branch current. We can tell that our I1, we have the same values as the small I1 because this capital I1 flows here and here and here, and then this small I1, this mesh current flows here too. They are the same direction, and that will be minus 0.86 ampere. Now for the capital I3 flows here, here and here. Why this I2 flows like this? So why the two have the same value? Because I2 is still what is flowing here, here and here. They are in opposite direction. Because they're in opposite direction, you see, I2 is going like this now, and this small I2 is going like this. So it's going to be negative of the I2. They are in opposite direction. The same magnitude, but the same different direction. So this will be minus 0.29 ampere. And then lastly, to read our I2. So I'm going to say, to solve that now. To solve that now, our I2, I'm going to say apply Kirchhoff law here and this node here. If I apply Kirchhoff law there, let me call this node B. Entering. Which one is entering? Only I1 is entering. I3 is leaving this node and I2 is going away from that node. So it will be I1 entering is equal to I2 plus I3. Hence, I2 will be equal to I1 minus I3. That will be I2. So if you subtract minus 0.86 minus 0.29, you get your I2. So this will simply be minus 0.86 plus 0.29. That's our I2. And so if we do that, we should have our I2. If we sum this, we get our I2 to be equal to minus 0.57. So that's about that. Mesh analysis with current source. In the previous examples we've solved now, there weren't current source in the question. All we have is voltage sources. But for this question now, in this case, we want to consider when we have current source, because in some questions you could actually have current source. How do you go about them? Well, we have two different cases actually under this mesh analysis with current source. In the first case, we just have a branch, or sorry, a mesh that has current source, and that current source belongs to that mesh. Okay, look at this now. This 3 ampere belongs to this mesh alone. So how do we analyze this question? Well, this is very, very simple. We can say easily set your I2. The current here is same as the current here because this 3 ampere is what is flowing here. And remember, it's just like the branch current. And so it's having the same magnitude as the I2, but opposite. You see the direction we gave for I2. I2 is going like this, while this 3 ampere is going like this. So they are the same, but opposite in magnitude. So we can say I2 is minus 3 ampere. So we've gotten our I2. Very simple. Had it been this question said that this current was like this, then I will say I2 is equal to 3 ampere. Straightforward. But that was not what they gave to us. It was given like this. And so I2 is minus 3 ampere. So that's all. So I will now apply KVL to just mesh 1 because I'm looking for I1. So for mesh 1 now, we've got our I2 already. So for mesh 1, this is 10. I'm going like this because of this guy. Minus 5 I1 minus 4 into I1 minus I2 for this part. Nothing else to read in this mesh, equal to 0. So simplifying, 10 minus 5i1 minus 4i1 plus 4i2 is equal to 0. So this will give us 10 minus 9i1 plus 4i2 is equal to 0. So bring this one to this side, will give us 10 plus 4i2 is equal to 9i1. Now let's put in the value of our i2. i2 is minus 3, so this will be 10 plus 4 into minus 3 is equal to 9i1. So this will be 10 minus 12 is equal to 9i1. So we can say minus 2 is equal to 9i1. And then dividing both sides by 9 now, our I1 will be equal to minus 2 over 9 ampere. So that's that about that for this question. So this is quite an easy one. There could be more complex ones than this, but this same principle guides them all the time. Mesh analysis with current source, case 2. When a current source exists between two meshes, as we can see in this case now, this current source is in between these two meshes. So we solve it differently actually. So in analyzing a kind of circuits, or this case, we create a super mesh. That's just what we do here. We create a super mesh, and that super mesh is obtained by removing the current source and every other thing in series with it. That these two ohm resistors will be removed. Then we create the super mesh. Well, we're going to do that in solving this question. So example 1, find the circuit below. Find the circuits. For the circuit below, obtain the mesh current I1, I2. I read wrongly. So to solve this now, first of all, before removing super mesh, you get our equation 1. To get the equation 1, we know that this 6 ampere is as a result of these two currents, I1 and I2. How are we going to do that? I'm simply going to write that 6 ampere is equal to, now, is equal to what? If you check very, very well now, it is in opposite direction to I1. How? The 6 ampere is going like this. Why this I1 ampere will be flowing in opposite direction? So it's in opposite direction, that is minus I1. Meaning the 6 is in opposite direction to I1, that's why I say minus. And then if you look at I2, it's in the same direction with it, because I2 will point upward in this middle part. So plus I2. We can simply say that, bringing this one here, 6 plus I1 is equal to what? I2. This becomes my equation 1. Then we now go ahead to form the super mesh. To form the super mesh, this is how it's going to look like. The 6 ohm resistor, the 10 ohm resistor, the 4 ohm resistor, and then the 20 volts. So 20 volts, 6 ohm resistor, 10 ohm resistor, and 4 ohm resistor. Remember now, I2 flows here, right? And what flows here? I1 flows here. So this will become, this is a super mesh now, a super mesh. When you remove the middle part, the current source and the resistor in series with it, you form a super mesh. So this will be plus 20, yeah, minus 6 I1. Then for this, minus 10 I2 minus 4 I2 is equal to 0. I've summed up all the voltages using KVL equal to 0. So what flows here is I2, what flows here is I1. Then we can go ahead now to simplify that equation. To simplify that, we have 20 minus 6 I1 minus 14 I2 is equal to 0. So we can say 20 is equal to 6 I1 plus 14 I2. This is my equation 2. And then, but from equation 1, we've already said that I2, so that I2 is equal to 6 plus I1. So replace that here. This will be 20 is equal to 6I1 now plus 14. Instead of I2 now we have 6 plus I1. So this will be, we're going to have 6I1 plus 84 plus 14I1. And then bringing this 84 here, 20 minus 84 gives us 6 plus 14, that's 20I1. This will be minus 64 now is equal to 20I1. Dividing both sides by 20 will now give us I1 to be minus 3.2 ampere. So we've gotten I1 now. To get I2, remember we have this equation, equation 1, that says, but equation 1 says I2 is equal to 6 plus I1. So simply this will be 6 plus, what's our I1? Minus 3.2. So this will be 6 plus times minus is minus 3.2. So our I2 will be equal to 2.8 ampere. So that's that about this.